Good day, everybody. This video is meant primarily for the Buck Mountain students who are enrolled in Physics 30 this semester. Just a little bit of a preamble. I'm going to be going through how to answer the questions and solve the problems on this quiz for the Buck Mountain students. The version for the quiz that's written by the Buck Mountain students was different than two of the versions that were written in Wetaskiwin Comp. So if you're a Wetaskiwin Comp student and you're looking at this, the questions are the same, but they have slight variations, whether it's different numbers or different choices in a multiple choice. The second thing to note is, and this is directed specifically to the Buck Mountain students, to the two Buck Mountain students who wrote this, since we weren't able to get you into Physics 30 at Wetaskiwin Comp until the fourth day of classes, you missed the first 3 lessons. And to those 2 students, they've reached out and they've asked me, can they do a rewrite? And the rewrite will be Wednesday of this coming week at noon. I just want to make sure that you understand this quiz covers lesson 1.1, which dealt with momentum, 1.2, which deals with impulse, 1.3, which deals with area, and 1.4 part 1, which deals with basic linear collisions. Nothing on this particular quiz had area on it. But it could be that for the quiz you write on Wednesday, there might be something with area. And the overall point I want to make is, don't expect this rewrite quiz that you're going to be writing to be these same 5 questions with little variations to them. They could be different questions, right? So let's get to it. A 240-gram rubber ball hits the floor with a speed of 5.2 meters per second and bounces up with a speed of 4.5 meters per second. What is the impulse? We've learned that impulse, one of the ways to find impulse is to say it's m delta v, but you need to remember that v is velocity, so the impulse will be the mass times the final velocity minus the initial velocity. And we can go ahead and put in the numbers. The mass needs to be in kilograms, so that would be 0.24 kilograms multiplied by VF. Now, we need to be very careful here. The ball is initially moving down at 5.2 meters per second. So this velocity, if you think about the ball moving towards the floor, the initial velocity here is negative 5.2 meters per second. When the ball bounces back up, its final velocity is positive because it's moving up. And if you watch the video I prepared for the lesson on impulse, I gave you a diagram, or I created a diagram that looked something like this. When you have the ball that is moving down, just before it hits the floor, its velocity is downwards because it's moving downwards. This velocity is not just 5.2, it's negative 5.2 meters per second. And then when the ball rebounds, then it's moving up. It's not moving up as fast, but it is moving in a positive direction. It's moving up at positive 4.5 meters per second is the velocity because of its direction. And if you don't include that negative in the initial velocity, you will get this question wrong, which means you get question 2 wrong as well, by the way. So VF is 4.5 minus VI, which is negative 5.2. We grab our calculator and roll these numbers through it and see what happens. 0.24, 0.24 multiplied by, in brackets, 4.5 minus negative 5.2 gives me an answer of 2.3 Newton seconds. So the answer is 2.3. Well, we take a look at number 2. You know, this is just the way of the world sometimes. Unfortunately, if you don't get question number 1 right, you're not going to get question number 2 right. Because question number 2 is asking you to find the force applied to the ball if the time that it's in contact with the floor is given to you. And we already know the impulse. One of the things we learned in lesson 1.2 is impulse as well as being equal to m delta v, is equal to f delta t. So we can take that impulse of 2.3 and set it equal to f delta t, and it becomes a simple matter now of taking the impulse that we found and dividing by the time. I don't really care on quizzes, especially this early in the year, whether you use the 2.328 or the 2.3. If we use the 2.328, you get a force of 19 newtons. If you use 2.3, you probably get the same number. It still rounds to 19 newtons. So the answer is 19 newtons. Before I move on, just a note, you certainly didn't have to do it this way. What you could have done is you could have used m delta v equals f delta t and put in those same numbers that you had before, where we had, I think it was 5.2 minus negative 4.5. I better double check. Got it backwards. 4.5 minus negative 5.2. I mean, you certainly could have recalculated that m delta v as part of your work here. In other words, you could have just used this entire line, which is the formula from your formula sheet. These two questions together, everybody, are classic questions on exams and quizzes in this unit. I could give you a similar situation, except instead of having a rubber ball falling and then bouncing up, I could tell you that you have a golf ball which is moving west and it hits a tree that causes the ball to bounce east. The bottom line is to find the impulse. It's m times vf minus vi, where vf and vi are vectors, and we need to include the direction. By the way, going back to my comment about what might be on the quiz you'll write on Wednesday, I could ask you for the change in kinetic energy as well. But when you find change in kinetic energy, and this is in your notes, there might be an example in your notes in 1.1 or in 1.2. When you find a change in kinetic energy, everybody, you're not worried about direction at all. You're just going 1/2 mv squared minus 1/2 mv squared. But 1 and 2 are classic kind of examples that you can expect to see on exams, quizzes, that type of thing. Number 3, all of you were here for the lesson in which we learned about different systems and different types of collisions. So this was not something you missed. You should know that when we talk about systems, in which collisions occur, a system can be classified as isolated or as non-isolated. I want to spend some time going over everything here regarding this and then cut to the chase. Well, let me cut to the chase first. If a system is isolated, then the collision that occurs in the system must be conservative with regards to momentum. Momentum must be conserved. If a system is non-isolated, then momentum is not conserved. Now, I'm telling you in this question that the momentum was conserved, so that means it's isolated. I don't have to tell you that directly. I could give you a chart like we have in lesson 1.4, which you were here for. I could give you a chart in which you have to look at the chart and decide if momentum is conserved. One of the other things that you need to know here is the total net force in an isolated system is 0, but the total net force in a non-isolated system is not 0. What that means is during a collision that occurs in an isolated system, the force that the bat exerts on the ball is equal but opposite to the force that the ball exerts on the bat. So when you add up all of those forces, you get 0, and that leads to conservation of momentum. I could go even further and say that in an isolated system, if momentum is conserved, the impulse experienced by one object is equal but opposite to the impulse experienced by the other. The other aspect of this is the type of collision, which is either elastic or I guess we typically use the word inelastic. Elastic or inelastic. And this has to do with kinetic energy in the system. If it's elastic, kinetic energy is conserved. But if it's inelastic, kinetic energy is not conserved. And that's the memory part of it. The understanding part of it is that when two objects collide, the only explanation for energy, kinetic energy, not being conserved is some was lost. And as it was pointed out in class, and again, this whole thing is from the lesson that you were here for, as was pointed out in class, that loss of energy is primarily what we call thermal energy. And another word for thermal energy is heat. So now putting this all together, if a collision occurred in which momentum was conserved, that means it must be isolated. That means the collision must have occurred in an isolated system, so we can right out of the gate take C and D and throw them out. These are not correct. And then we're told that heat was produced. If heat is produced, it's not elastic, because if it were elastic, kinetic energy would be conserved and there would be no heat, which means the correct answer is B. When we look at number 4, this is from lesson 1, where we reviewed scalars and vectors from physics 20. I would say, though, that we've talked about scalars and vectors enough that you should know that anything with a direction is a vector. From physics 20, you should know that acceleration has a direction, so it's a vector. From this course, man, I've harped on it enough that momentum and impulse are vectors, and you should know force is a vector anyway. And impulse is a vector here. The only thing that we're left with that is a list of scalars is choice C. And I don't really know how else to explain this other than to say you need to know that scalars have no direction. Energy doesn't have direction. If I say how many joules of energy are in that double cheeseburger you ate, and you give me an answer, I don't know what it would be in joules, but you say it's 800 calories of energy, it's not 800 calories of energy north or south or towards the ceiling. It's 800 calories. Charge, I've mentioned a few times in passing that this is a quantity that is just, it has to do with electrostatics and electricity. It just has to do with how many electrons there are in the system in an indirect way. And mass, you should know mass has no direction. So all of those are scalars. Number 5 is a problem from lesson 1.4, which all of you were enrolled in the course during. We need to remember that during this collision, since no significant forces of friction were present, that's our code words to tell students that momentum is conserved. It's our way of saying that the system is isolated. So you're going to say MV, well, you're going to say momentum before equals momentum after. You do need to remember that objects that move to the right are going to be assigned a positive velocity, and objects that move to the left are going to be assigned a negative velocity. And we did lots of these questions in this lesson, and you were assigned lots of these questions. So if you were not able to get this question, that has nothing to do with you not being enrolled in the course yet. You just have to work harder at that lesson 1.4. I'm going to put in the momenta. MV for the 33 kilogram object before would be 33 times 2.4. It's moving to the right. I mean, if you want to be clinical about it, we could write plus there. We could say it's positive. It collides with initially a 25 kilogram object that is moving to the left at 2.1 meters per second, which means that is a negative velocity, and we need that in there. After the collision, what do we have? The 33 kilogram object is moving to the left at 0.35. So its velocity is negative 0.35. And the question is, what is the velocity of the 25 kilogram object afterwards? Really, I mean, these are just numbers. Some are positive, some are negative, but this is a very basic, almost grade 8, 9-ish linear equation to solve. I would say that you should be able to solve it pretty much on your calculator, but I'm not going to do that. If I take 33 times 2.4, I get 79.2. 25 times 2.1, well, negative 2.1 gives me 52.5, so I have minus 52.5 equals, I need to take 33 times negative 0.35, negative 11.55, plus 25V. I mean, the rest of this is pretty simple. You're going to simplify what we have on the left-hand side. Then you can go ahead and add 11.55 to both sides and be left with 25 VF. Let's see what we get here. So 79.2 minus 52.5. Gives me 26.7. I need to add that 11.55 from the other side. So I get 38.25. And I get a positive number. As I mentioned in one of the videos for one of the lessons, it's one of the things I like about science and physics, is the math doesn't lie. If you set up the physics properly, and the physics is this statement. The substitution is still physics, but then the mathematics of it, it won't lie. If you set up the physics right, the math is not going to lie. So the fact that we got a positive when we divide that by 25 tells us we get a velocity that's positive for the 25 kilogram object. So when we look at our choices here, everybody, it's 1.5 meters per second to the right because it's positive, so the correct answer is B. Just a quick note again about the quiz that the 2 Buck Mountain students who wrote on Friday will, quote, rewrite next Wednesday. It can be on anything from section 1.1 up to 1.4 part 1, not including the ballistic pendulum stuff and all that. To the 1 Buck Mountain student who did not write the quiz because they were absent, as long as that absence was legitimate, you'll be writing that quiz, a different version of the quiz, on Monday. And if you so choose to rewrite after seeing the results of that quiz on Monday, then you can do so Wednesday as well. And that will be Wednesday at lunch. And Mr. Moore and I will set that all up and get you guys going. And hopefully from here on in, that'll get you back on track with everything that we're doing. I hope that's helpful. I did spend some time making videos of those 3 lessons, and I will post them at the same time as I post this one. So I hope that really helps. Spend some time over the next few days going through those first 3 lessons if you need to get ready for that quiz, and also, I guess, to get ready for your unit exam, which is coming up shortly. I hope that you all have a wonderful rest of the weekend, and I'll see you all in class on Monday. Take it easy, you guys.